Now, if I'm moving this cup like this,
Mm-hmm.
do you think that if it takes 2 seconds for you to plan, will you ever grasp it?
No, I don't think you're
No,
going
right?
to be able to.
So that is the real power of hardware acceleration, that you do have a chance to compute really fast what you want to grasp and then execute.
Hey everyone, welcome to another episode of Behind the Tech, and this one we're going to speak with my friend Víctor Mayoral, someone who's been in the drone industry and the broad robotics industry for more than a decade, and he talks about hardware accelerated robotics and why that matters.
You had a talk in Roscon that I actually missed, but I really was looking forward to, and I'm going to watch that recording. But the topic is really important to me, hardware acceleration.
Right.
Why are you interested in this?
So hardware acceleration can revolutionize robotics. I mean, it can allow us through specific accelerators, pieces of hardware, to speed up robotic computations through the means of an FPGA, a GPU, or other accelerators, TPUs, MPUs, and others. We can actually get robotic computations twice as fast, or 500 times. I showed evidence during my talk how some perception computations, we showed literally how with an FPGA we could accelerate them 500 times more when compared to a GPU. And
500 times.
Yeah, 500 times more. And again, it is in the recording. The data we use to produce that is open source in the ROS2 hardware acceleration working group, which actually brings me to my interest. So again, there's this belief and right now evident that indeed hardware acceleration can completely turn robotics around. We can have faster robots, more reactive, more real-time, more power efficient as well, because at the end, a robot is a deterministic machine.
Yes.
Robots are all about real-time. It's possibly the most important characteristics in robots. So we can really guarantee this, and we can do so because again, CPUs are general purpose computers, memory-centric ones, wherein they often do best effort for what concerns determinism. There's only so much we can achieve. However, if we build custom computer architectures via hardware acceleration, we can actually just feed particular computations, and this spreads across use cases. It goes all the way from walking robots and drones included as well. Actually, I would say that in this conference we had actually repeated talks that emphasized hardware acceleration.
Yes.
I'm actually super surprised how pretty much everyone I spoke to was interested in diving into hardware acceleration.
Like the very first talk, actually, the one that was during the surgeries, like they were talking about and how that was a limiting factor to them.
Exactly.
And something they needed to improve.
Yeah, and that is, I guess, then back to my interest. So we noticed this actually quite a few years ago, when we were building still autopilots in my first company, Early Robotics, we noticed it. And I'll get back into that later, I guess. But we realized it, so we started working initially with GPUs, NVIDIA TX1s at the time.
Yeah.
But then we bumped into some limitations and issues and pivoted into FPGAs. And that opened up the door for us to try different accelerators for different use cases. And it all ended with, me kind of like bring up this sub-community in the ROS world called the ROS2 Hardware Acceleration Working Group. It is a community working group which meets every month approximately. We started with 20, 30 participants on every meeting, and right now we have for the last meeting we have 350 attendees.
You invited me on LinkedIn as well,
right?
So you were doing your work.
Yeah, I was doing my work, right? And I think now for the upcoming one, which is November 3rd, I think there's already like 300 something. Registered attendees. So it is right now the most popular working group in the ROS community, certainly, and it is certainly capturing lots of interest across academia and industry. So super excited.
I could sort of feel like there was a trend within Roscon about that, but I'm a bit ignorant into what the actual applications, like examples that we could do in like tangible ideas. Like how can I achieve with this? How can this help me? Let's say in a drone.
Correct. So for the particular case of a drone, there's various tasks you may want to accelerate in terms of computations, faster computations or reducing the power consumption. The first one is probably the lowest hanging fruit, which is the one that I demonstrated in my talk, is perception. So the perception stack often takes a huge chunk of your computing systems while you're doing any sort of like autonomous drone task. So if you can somehow limit the amount of CPU you are consuming with those tasks, and you can push it or offload it into an accelerator, then those CPU cycles can be used for higher level tasks, such as better planning, better navigation, or even more complex tasks. So again, perception is a very, very well-defined use case. Accelerated navigation is also a pretty easy to understand one. Right now, often the case when you are navigating around a place, every time that the environment changes, you need to recompute often your plan, and that recomputation takes some time depending on your parameters, your algorithms, the environment, and the sensors you process. This recomputation can actually be accelerated in navigation, and similarly also in the case of manipulation. I know it's not so common yet to do manipulation on drones, but there are some ongoing projects actually that are attaching manipulators into the drone. And so right now with Moveit, for example, which is the default manipulation stack in ROS 2, the most popular one at least, every time with a decent modern computer, every time something changes in your manipulation plan, when you are planning a grasp, you need to recompute the grasp, and this can take up to 2 seconds. Now if I'm moving this cup like this, do you think that if it takes 2 seconds for you to plan, will you ever grasp it?
No, I don't think you're
right?
be able to.
So that is the real power of hardware acceleration, that you do have a chance to compute really fast what you want to grasp and then execute. And then it's up to your actuators. Maybe they are not fast enough and they will still...
But that's a different problem.
Exactly.
Yeah. Okay, that's great. And I saw you also run a survey within the conference. I'm like, okay, what is the most important thing to you when doing hardware acceleration?
Yeah.
And the response was real time, right?
Correct. Yeah. So, and again, that confirmed kind of the hypothesis we had quite a while ago, and the one we've been using to drive our work, which is that people really focus in the robotics domain in making sure that their systems respond in the well-defined timings they do specify, so that actions make sense. And on that, we are increasingly being more and more surprised. Muchas gracias, sí. Muy amable. How essentially people keep that at the top of their list. The second one is determinism, things happening exactly in the same order, and essentially every single time. I don't know if surprisingly or unsurprisingly, we do see. Muchas gracias. We do see that people do not seem to care so much, at least in the ROS community, about power consumption. It was actually the one last cited, and that is, to me, a bit surprising, because mobile robots are all kind of limited by their
operation time.
Exactly. And so I think that in the drone space, I think that is something we care a lot about, because we are used to having bulky systems with 15-minute, of autonomy. Maybe if you to optimize your system appropriately, you get to 30 minutes.
You're lucky if you can get 30.
Right. But way beyond that typically requires you to move beyond electrical drones and go into some alternative source. I've seen some of those. We've built some of those. But yeah, the fact is that you could significantly lower the computing power consumption by means of hardware acceleration as well. So hopefully over time, people will also start paying attention to this. I think the drone space is a bit interesting because still I think the major source of energy consumption are still the rotors, the motors themselves, but there are ways also to try to reduce that. I think UPenn showed a fantastic case study. I don't know if you had the chance to watch that talk, but they spoke about how they are rotating, they are using big propellers, and they are rotating slower, so that essentially they can reduce the power consumption there. So pretty interesting.
Who gave that talk, Fernando?
Fernando.
Okay.
Sí.
Yeah. Okay.
Yeah, and he did an amazing job. I made sure to speak with him because their lab is actually working on super interesting stuff that does require and can only be possible if you use hardware acceleration. They do have some kind of needs wherein the autopilot itself needs to actually evolve.
Yes.
And turn into something that exposes information at the IMU level, gyroscopes, magnetometers, and so on and so forth, outside of the current autopilot black box that often the case we use to build drones, and into the ROS world, so that more complex behaviors can be enabled.
That's interesting, because right now we've been treating the autopilot more like a black box.
Right.
And it's been working so far, but how do we get that out and how do we extend it? And it's a limiting factor at some point, because you got the flight controller, you got the data there, but if you want to change anything, you have to actually go there and change that, and then you're limited by the capacity of that flight controller when you can actually have a companion computer that is much more powerful to do those computations. Can I take this back a little bit to the work group? I'm interested in to know like what's the focus of the work group? Like I know like it sounds very broad to say, hey, let's do hardware acceleration, but do you define the actual goals behind the work group?
Yeah, great question, and sure. So the working group, the ROS2 Hardware Acceleration Working Group, focuses on driving the creation and maintenance of essentially hardware acceleration kernels in a vendor agnostic and accelerator agnostic manner. That means we make sure to develop the technologies required to enable ROS developers to build computational graphs that leverage hardware acceleration. Technically speaking, our contributions focus on four key aspects. First, we extend the ROS2 build system to make sure that they can build against and targeting different accelerators. Again, FPGAs, GPUs from different vendors, but also other accelerators. And let me make a small parenthesis in here. One thing that people is not so aware about is the fact that modern SoCs, modern chips, pack a huge amount of accelerators. If you open up the schematics of a modern Qualcomm computing system, SoC, you'll notice that they have quite a few specialized accelerators, and leveraging those is really cumbersome. You need to use specialized APIs, and it's definitely far from compiling with GCC or whatever you commonly use. So what we are doing in this working group is, again, just enabling at the build system level the capabilities to go against each one of those. So that is the first contribution. The second contribution is that we don't only extend the build system, we also extend the build tools, so that when you Qualcomm build your workspace, actually you can select dynamically against which one of the accelerators you want to go, so that you can, by simply using something called ROS mixins, which are extensions to the existing meta build tools, Qualcomm in the ROS world, you can, again, just with a simple argument in the command line, you can go against accelerator A, then B, then C, everything in the same workspace, which speeds up the development significantly. That's the second contribution. Then there's a third and a fourth, which, to keep it simple, we pack and abstract away the complexity of the different frameworks for hardware acceleration in something we call a firmware layer, which allows you to switch between them while remaining agnostic to those technologies to a certain extent. And then the fourth one is building upon prior work. We actually leveraged low overhead tracer for real-time tracing and benchmarking, which allows us to do performance benchmarking of computational graphs that can be used across essentially various setups using hardware acceleration and without it, which allows us to compare and also devise and design improvements. And this is crucial. In hardware acceleration, we need to approach the problem with a very quantitative approach. We need to know where we start from, and at every single point, we need to fairly compare various accelerators to know which one is the right one for our use case. Often the case we have an intuition, but we want to be very strict and quantitative. And actually on this, I can say there's a fifth kind of like contribution that's being cooked. And that is an official formal benchmark in robotics. And this is something I'm going to discuss in the next upcoming working group meeting. For those familiar with the AI world, you might have heard about ML Commons or ML Perf. That's kind of like the de facto standard right now.
Yeah.
So we are creating something called Robot Perf. And maybe drone perf makes sense, or maybe it should be part of robot perf.
It should be part of robot perf. Like we should, as much as possible, try to standardize on robots because we're already too much further into our bubble that we need to.
I like that. And that dives into what you were saying about autopilots, and I do have some ideas and some thoughts definitely on that bring me back to when I started working with these technologies back in 2011, 2012. Where I had, my disagreements with Philip Ross, who was at the time creating Pixhawk, Fire Cape.
The 2.1.
Yeah. At the very beginning, we were like creating a cape for the BeagleBone Black. So like a hat that allowed to run Autopilot and Linux. Then we kind of like engaged with Lawrence Meyer at the time, who was driving PX4, and we had some discussions on whether our work on Linux could be brought into PX4. So at that time, from a hardware perspective, we were having some discussions around how do future autopilots should look like, right? And I was at the time a PhD student and inexperienced, but with I guess, some pretty strong opinions about what I thought should be doing. We should be doing, and those came from the fact that I had worked with ROS for many years already. I was pretty early into ROS. I had contributed to various ROS packages, and was behind also the Meta ROS package, which brings ROS into the Yocto/Open Embedded world, which is used in production environments. So I did know quite well the ROS world already, and I was sure that the convergence was the future about it. And I was looking at it from a robotics perspective, not maybe from a drones perspective. And so I always thought that, if we wanted real capabilities, we had to expose some of the autopilot aspects into the computational graph, into the ROS computational graph. And bridges were great, but they weren't performing good enough for us to fully exploit it. And I showed this in various tests I conducted, and I complained about it. So I started creating my own autopilot that actually had this capability. So technically, what this means is that you smash together the autopilot and the companion computer. And at the time, there were lots of critical voices. Like, no, you don't do that due to safety reasons. And I was like, safety? I mean, we were working with STM32F4, guys, come on. Like, if you want safety, just synthesize that PX4 code into an FPGA, into a soft core. And then we can speak about redundancy and having, redundancy and then kind of like coherence. At least two instances should be agreeing on what to do. Which is, by the way, what happens in commercial autopilots. That's how they are built. And I was lucky to be involved in part of that in some prior experiences. So that is the way we're looking at it right now. That's one of the things we're thinking about right now. And yes, I was telling you before, with some, we believe, new and novel ideas, which replace the PX4 communication middleware to try to bring it closer to the ROS world.
Yes, and you were involved with micro ROS too?
I was part of the, I guess I should say, the architecture definition. I was, I guess, the number 2 group in the consortia, and then we brought over, and I did part of that work to engage Bosch and to engage a few others. And yeah, we kicked it off. I was part of the consortia. We helped out with hardware. That was the role of my team at the time. But for various reasons, we disengaged from the project. But yeah, I was part of it. I've been working with MicroROS for quite a while.
Yeah.
I know it reasonably well. Also know the limitations, both security-wise and performance-wise. That is why nowadays many people in the community actually is pivoting from MicroROS into other alternatives that do allow for direct interoperability with ROS2. There was 2 projects presented this year. One was MROS, coming from Japanese university. And the other one, which we all know, is Embedded RTPS, which is a microcontroller-oriented RTPS implementation that allows direct interoperability.
It's interesting to see your sort of your journey. You started in the sort of like a drone space with earlier, and you saw that there was a need to evolve the hardware because there was a certain limiting factor there, and then you started moving up the chain, and now all the way into accelerating robotics, and it sort of like makes sense. And what made you drive that focus into this? Why do you think this? It sort of feels like you have a plan since day one, or are you making things up as they go?
No, I think we. So I personally think I've always kind of like followed the same direction. There's been branches, I must admit. Like right now, I am. So I'm the founder of 2 ongoing running companies. One which is running on its own, Alias Robotics. They do robot cybersecurity. So I founded Alias in 2018. Helped a lot in the first few years, bringing it up to speed. They focus mainly on robot cybersecurity services, mostly offensive ones. They hack robotic companies on demand so that they don't get hacked before. And we do lots of like pen testing and threat modeling. And I've worked with like the cool guys in the robotics community, like the big guys in the ROS domain have been partners and clients. We've worked with Open Robotics, Apex AI. And Alias does well on its own. It continues with its service business model. And yeah, I once they were running on their own, I started focusing on Acceleration Robotics, which is the company. Right now I am mainly leading. And we are actually, again, doing hardware. That's what we've always been doing since the times of early robotics and all the way into acceleration robotics. With early, we prototyped first with Raspberry Pis. We were making autopilots with Raspberry Pis and reasonably successful at that. We sold a few thousands of actually autopilots in a very short period of time. Then we pivoted into building tiny, kind of like professional grade autopilots using FPGAs. And that's where we first got in contact with this technology around 2015, and then we got acquired for that technology, which ended up being used in another domain. But at that point, I kind of like, had this feeling of, wow, I want to continue this story and bring it to the end, and for reasons related to the operation and the acquisition, I couldn't at that time continue with that road. I had to focus on what the group wanted for me. But yeah, after a few years and now another company. We have the vision, we have the experience, and right now with Acceleration Robotics, we are serving some of the biggest semiconductor companies in the world. We are either cooperating with them or partnering with them closely for hardware acceleration and for bringing it into the ROS world. But as you were saying, we do see a continuum. We don't see separated communities. Especially with ROS2 and PX4. I think there's been great work from Tali and from you to bring things closer. And on that, I can only say that I do see that work very clearly. I appreciate it. And on our side, on the hardware side, we do have some ideas to how to smash it, which we believe will empower new use cases. As I was telling you in the backstage, there's some ongoing work that I just became aware throughout the last few days about some manipulation on top of, or I should say, some drones with grippers attached and that do perform manipulation with various degrees of freedom. And there seems to be a big interest around these things, and this can only happen if you have like direct access to the IMU data, so that the dynamic computations can happen at loops of certain rate.
Did you see the demo? Are you talking about the demo? I think it's EPFL, where the drone flies and grabs the ball from the middle and just goes back and drops it in the same place. Is that the same? Is that the project you're referring to?
So that is one similar to a certain extent demo. UPenn is doing many others as well, where they are perching themselves into various places. And now there are others working on maybe derivatives of that with higher degrees of complexities, which again demand from the get-go not only access to additional data, but also literally hardware acceleration to free space for additional computation, to increase the amount of data. And again, it's not just related to one use case or the other. Increasingly, we are seeing how more and more robots pack every single year more and more sensors. And so this means that we need more specialized systems.
The amount of data is just incredible.
Yeah, it is. It is. And as we saw in some of the talks, we can't just store everything. Like, we need systems that somehow create, I would say, a way for us to process everything on the edge. And the cloud, there's lots of work going on the cloud. And I did cooperate with Berkeley over last year on building a FOC-ROS2. FOC-ROS2 is a project that allows you to grab your computational graph in ROS2 and grab a few nodes and push them into an AWS instance, CPU instance, directly from the launch file. Super easy. We did work on this, and we demonstrated it. I helped bring up the architecture. I worked together with some Berkeley super talented folks. And then from that point, we at Acceleration Robotics forked that project and demonstrated not only how you can do that with CPU instances, but you can also generate acceleration kernels for big GPUs in the cloud or big FPGAs.
I think I was talking to Camilo from AWS about this.
Camilo knows this, and he asked me for references, and I need to catch up with him actually, because he'd like to learn more. This is a fantastic use case because it's something new. Like, so far people just believe that they can use the CPUs in the cloud. No, they can't use much more, and we've been showing that that the thing though is that even though you can accelerate a lot in the cloud, robots have, and will always have, that's my opinion at least, an edge intrinsic side of them. And that's not going to go away. That's really not going to go away, at least for high performing robots. Of course, you can offload much of the complex stuff to the cloud, and probably you should be doing it. But there are some things that always need to remain at the edge.
Yeah, you need to be able to make that decision real time.
Exactly. And we need to handle situations where there's no connectivity, and real autonomy requires edge capabilities. I'm a strong believer about that. And yeah, again, I think there's going to be convergence very soon, but I think hardware acceleration is also going to be the bridge to fully exploit these cloud capabilities, because we are not just speaking about accessing many CPUs in the cloud, but we're speaking about accessing FPGAs the size of this room.
Yeah. And when you were talking about hardware acceleration and then also PX4 and maybe looking into alternative middlewares, and it sort of looks like you have a goal in mind into how to liberate all this data and liberate developers to actually be able to focus on that so that they can actually implement that. What sort of hardware are you thinking? Like, what sort of hardware are you building to enable this?
So right now at Acceleration Robotics, I guess we focus on, I would say, well, mainly two things. First, we do acceleration services. We do robotics consulting, lots of it. And that's our main area of activity, I must say. We want to work with companies that have a need, a computational need, and we work with them to make sure they can meet those goals, computational goals. The second one is we're developing slowly, and as we believe the market's ready, products which mainly come in two forms. The first one is we fork ROS2 packages, and we add hardware acceleration to them. And we already have perception fork, which we call Robot Core Perception, and we have also Coordinate Transformation fork, TF2 in a nutshell, which again, both of them do comply with ROS2 APIs, meaning that you don't need to change anything in your code, to just git clone our repository, rebuild your code with the corresponding flag targeting the accelerator, and you're good to go. That is what we are doing, and we are thinking about which other packages we should be focusing on. We have launched surveys to try to identify what are those, and we have now data to process. And we're of course also looking at PX4. Maybe that is a candidate we should be considering. So that is an area of products that it seems to be demanded. The second one is we have released in an open source and open hardware manner, what we believe is the first candidate or instance of a robotic processing unit. This is essentially an assembly packing together GPUs, CPUs, and an FPGA. And we pack it in a box that I didn't bring today, I'm sorry about that. But I should have brought, actually. It's on our website nevertheless. And we open sourced and open hardware that in the form of the robotic processing unit. That's the name of the project. And we offer kind of like industrialized, ruggedized version of it, but we actually recommend people to build their own. We have released the bill of materials, the recipes, the 3D printing files. We encourage folks to build their own, and our work as part of the Acceleration Robotics, but also as contributors of the ROS2 Hardware Acceleration Working Group, is to use that as the reference blueprint to build acceleration. So that is also something interesting we're giving back, and which we would encourage listeners to check out.
Yeah, no, that's super interesting, because if you really want to push this forward, you actually need the reference design before it gets things started, because otherwise you're going to start fragmenting the space more.
Exactly.
You have this great idea, but then, okay, how do I build it? And that you have to really be aware of that before you start doing it. So what do you think is the timeline to see adoption on this?
¿Un poco más?
Sí, por favor.
Timeline for adoption. So, that's a good question. I would say that the timeline is now. I mean, like if we take a look at what most companies are doing, and there you go.
Gracias.
De nada. If we just take a look at and speak with the companies that were actually in the conference these days, most of them are actually changing and thinking of changing their computing architectures. That is the reality. Like the big guys that were selling thousands and thousands of robots, they were literally acknowledging, we're using Intel-based solutions, but we're now thinking of moving forward, and hardware acceleration is in our plans. And when you further query what are their plans, you do realize that most of them seem to converge towards certain solutions, which we don't have an opinion on, but what we do have an opinion is on how the ROS2 robotics community and how the overall robotics community should be thinking about integrating hardware acceleration. I am personally a bit afraid about two things. The first one is that there are some players in the market that have a humongous amount of resources on marketing. They overshadow everyone else.
Mm-hmm.
And they may not have the best technology for all of the use cases. Nobody has it, to be frank. But the reality is that that amount of marketing makes people believe that they should be the de facto choice, when frankly speaking, it depends very much on the type of robot you're building. Particularly, I can tell I'm a bit concerned about how NVIDIA seems to be trying to conquer the robotics world in the same way they did it with the AI world. Like if you ask any AI guy, they'll tell you, yeah, sure, are you doing AI? Of course you're using GPUs from NVIDIA.
Yeah.
However, if you do look at the benchmarks, you realize that there are solutions out there that perform way much better than NVIDIA GPUs. There's GraphCore, there's TPUs, there's other solutions, custom ASICs, which do way much better. But again, it's a marketing thing. And in robotics, we are increasingly observing the same. We are seeing how people just are not exposed, and often the case also the community somehow doesn't react good enough. So that is my first concern. The second one is that we are making efforts from the hardware acceleration working group to try to avoid lock-in. Because what happened in AI, and what is happening right now is that this is forcing the community to go into lock-ins. Lock-ins means that NVIDIA is in many cases breaking ROS2 APIs. They are breaking with the TF2 package. TF2 is a bad example, but image pipeline. They are forking it, often the case changing the license, which is forcing people to accept things they should not be doing, because I mean BSD and Apache 2.0 are really nice, commercially friendly licenses. We should be keeping and pushing for them. And besides the change of license, they are changing the APIs, which is essentially forcing people to change their source code, and then also locking them due to complexity associated into specific technologies. So what we are doing is trying to break with this, trying to say, no, we are going to present a series of reference conventions and a reference architecture. And silicon vendors, manufacturers of accelerators that want to, bring their technologies into the robotics ecosystem, please use these interfaces so that developers benefit themselves because they will only have to use one interface.
Yeah.
Package maintainers can, with one single definition, cover all of the accelerators, and hardware acceleration vendors have like a healthy, fair, competing landscape wherein they can really demonstrate their own worth, but without so many, non-technical hurdles.
Yes.
Which is what we are observing. So this is something I just wanted to convey, which is very important and which people should be mindful about. Fortunately, I can say there is a decent amount of investment that I can at least observe from particularly AMD. AMD is putting lots of resources and good engineering from inside to try to bring their technologies closer to the ROS community. So hopefully we'll get there.
Great. I think you're doing all the great steps that you have to do. Like you're working with open source community. At the end, the open source is the community and is the people, and it's important to make sure that everyone is aligned. So the work group is solving that, and then you're also trying to push this forward with open hardware. So I commend all of your work, and I hope that we really get to work closer to bridge the drone and robotics worlds together, because honestly it's the same problems, and we gotta stop pretending that we're so special that we don't need to help from each other. And we run out of time, and is there anything else that you think, let me put it this way, what is the thing that you think people should know about Victor that they don't know?
Well, that essentially I'm super thankful for everyone's work. This is not one person, one organization's work. This is all of us. So I guess just expressing my thanks to every single contribution, every single pull request. So that is one thing that you should know that I really feel. And the second one is that if you have a robotics startup or you're working in a robotics startup and by any chance you think that hardware acceleration can help you, reach out to Acceleration Robotics. We'll be more than happy to consult for you. We'll be more than happy to assess it at least, and definitely bring your computations faster.
All right, well, thank you so much, Víctor, y pues espero vernos pronto.
Nos vemos muy pronto.
Gracias.
Un abrazo. Muchas gracias.
Sí.
you.